Hello guys, this lecture of engineering mathematics on topic basic definition probability part 1 is brought to you by lecturesforfree.com. So guys, let's start the lecture, and first of all let's see what are the topics that we will cover in this lecture. We will see some basic definitions about sample space. Then we will see definition of a random experiment. We will see about events and the types of events, and we will also see definition of probability. We will see the definition of conditional probability. So guys, let's start with sample space. Sample space, it is the collection of all possible outcomes of an experiment. Okay, let's suppose our sample space means all possible outcomes of an experiment. Let suppose an example mm, if our experiment is like tossing a coin. Okay, or example is like tossing a coin one time one time. Let's suppose our experiment is this. So our sample space will be what? All possible outcomes. So if you are tossing a coin, if you are tossing a coin, then our all possible outcome will be either it will be head or it will be tail. Okay, similarly if your experiment is like rolling a dice, okay, one time, then our sample space will be what? All possible outcomes means if you are rolling a dice, then our outcome will be one. It may be one, it may be two, three, four, five, and six. Okay, so these are the sample spaces for this experiment. Sample is 1 2 3 4 5 6 is the sample space for rolling a dice one time experiment, and this head and tail is the sample space for tossing a coin one time. Okay, means sample space represents the all possible outcomes of any experiment. Okay, so let's see the random experiment. Random experiment are the experiments whose outcomes are unpredictable. Okay, whose outcomes are unpredictable is known as random experiment. Like a tossing an unbiased coin is a random experiment. It could be anything. It could be head or tail. Okay, we don't know, so it's unpredictable. So we will call it as a random experiment. And draw a card from a pack of 52 cards. Okay, so it will be also the random experiment. Now let's see the definition of events. The outcome of any experiment is known as event, or mathematically we can say that event is the subset of sample space. Like here, this is sample space for tossing a coin. Means if you are tossing a coin, means sample space is head and tail, means it could be head, it could be tail. So these outcomes are known as events. These outcomes are known as events. Like we can say getting head while tossing a coin is a event. Okay, similarly in rolling a die case, we can say that getting any number, like getting 1, getting 2, getting 6, um, is like a event. Okay, and we can say that getting even numbers while we are rolling a dice, it is also a event. Getting odd numbers while rolling a dice, it is also a event. Basically event is some outcomes or one outcome of the sample space. Okay, it is the subset of sample space. Okay, so our events is like getting head while tossing a coin one time, Okay, or you can say getting even number while rolling a dice. Okay, or getting odd number, anything. So now let's see the types of events. What is, let's first of all let's see what is complementary event. uh, if we are telling any event C, any event E, then we can call it complementary of this event like EC, or you can write it like E bar. Okay, so complementary of any event E will be known as EC or E bar, and it will contain all the outcomes, all the outcomes of sample space that is not in E. Okay, it contains all the outcomes of sample space that is not in E. Means, let's suppose our sample space for rolling a die, let's suppose our experiment is like rolling a dice. So our sample space will be 1 2 3 4 5 6. Okay, let's suppose our event is like getting a odd number. Okay, so we can write our event is like getting a odd number, means we can write it like 1 3 and 5. Okay, this will be our event. It is a subset of this our sample space. This is our event getting odd number. So our complementary event will be EC, or we can say it E bar. So it will contain all the outcomes of sample space that is not in this our event. So here in this event we have 1 3 5. So let's remove this event, these outcomes, and write the rest of the outcomes of sample space. So we can write is here 2 4 and 6. So complementary event of getting odd number will be getting even number. Okay, this will be the complementary event of this event. Okay, means it contains all the outcomes of sample space that is not in our main event. Okay, now let's see the equally likely events. Two events E and F are said to be equally likely if their probabilities are equal. Means probability of E is equal to probability of N, so probability of F, then we can call it as a equally likely events. Okay, we haven't seen the main definition of probability, we will see it later, but for now we can understand this. If their probability will be equal, then it is known as equally likely events. Okay, so let's move further. Mutually exclusive events. Mutually exclusive event, this is important. Okay, so any two events E and F are said to be mutually exclusive if there is no common outcome between that, no common outcome in E and F. Okay, it means we can write it as E intersection F. Okay, this represents the intersection sign, means it represents the common factor in common outcomes in E and F. So we can write it E intersection F is equal to phi. Here phi represents the null set. It represents the null set. Means um, E intersection F is equal to nothing, means null set. Okay, so mutually exclusive means there is no common outcome in E and F. Okay. Now next is the collective exhaustive events. Two events E and F are said to be collective exhaustive if these both events gives complete sample space. Complete sample space. It means E union F. It represents E union F. It means outcomes of E as well as outcomes of F both combined together, then it will give us sample space S. We are representing sample space as S in letter S. Okay. So collective exhaustive events means this, if these both events combined together, then it will give complete sample space. Then these events will be known as collective exhaustive events. Okay. Now let's see the independent events. This is also important. Okay. Two events E and F are said to be independent if probability of E doesn't affect F has happened or not. F has happened or not, and vice versa. Okay. Means probability of happening of E doesn't affect the probability of happening of F, and probability of happening of F doesn't affect the probability of happening of E. Then these two events are known as independent events. Okay. Uh, in mutually exclusive events, we can say that generally people get confused with mutually exclusive and independent events. Uh, okay. So let me tell you one main difference. Means mutually exclusive will be it will be on same sample space. Okay. But in independent events there will be sample space will be different. Okay, we will see it by Venn diagram, then you will get more idea. Okay, we will see it by Venn diagram. Let's see some Venn diagram, then we will get more idea. Let me make it like this. Okay. Let's suppose this represents E, this represents F. Okay. So and this rectangle is representing our whole sample space. This rectangle is representing whole sample space S. This circle is representing the event E, and this circle is representing event F. So this reason, okay, this reason will be our E union F. Okay. Now let's see again. Let's suppose this rectangle is representing our sample space S. This representing E, this circle, and this circle is, let's suppose, representing event F. So this reason is your E intersection F. Okay. Let's suppose this is our sample space S. This representing our, this inside is representing our E. This inside region is representing event E. So this outside region will be our region E bar, or we can say EC, means complementary of E. Okay. And let's suppose this is our sample space, and there are two events like E and F. Okay, there are two events like E and F, and this is like this, means there is no any common outcome. Okay, here we can see this is totally E and this is totally F, and there is no there is no any common area between this. So this type of events we call it mutually exclusive events. Mutually exclusive mutually exclusive events. Okay, sample space is same, but there is no common outcome in E and F. Okay, so this type of events is known as mutually exclusive events. And let's suppose if we have like this is one sample space S1, and here it is E. This is another sample space E2. Here sample space is 2 and it is F. So here sample space are different. So, and means probability of happening of E doesn't affecting the probability of happening of F. Okay, so this type of events is known as independent events. Independent events. Okay, so independent events is an example of this is like if you are if you are tossing a coin two times, so our first time result will not affect our second time result. Okay, so like tossing a coin two times is like they both two times are like independent from each other, so it is like that independent events. Okay, now let's see the definition of probability. The probability of an event is defined as the ratio of number of ways an event can happen to the number of ways sample space can happen. Okay, I think it's clear. Like let's suppose our sample space is like 1 2 3 4 5 6. Okay, so number of times sample space can happen is like number of ns is like here 6. Okay, this is sample space for rolling a die. So probability is nothing but the ratio of number of uh, events any event can happen divided by the number of sample space can happen. Okay, so like our sample space is like 1 2 3 4 5 6. We have, if you are rolling a dice, then number of elements happen, we can say number of outcomes is like 6 here. Okay, 1 2 3 4 5 6 6. Let's suppose our event is like getting a odd number. Getting a odd number is my event, so we will get outcome like 1 3 5. Okay, so number of outcomes will be a number of ways it can happen. Okay, here it is written number of ways an event can happen. So how many number of ways means 1 3 5. So there are three ways that this event can happen. Okay, if it will be 1 3 5, then this event can happen. So number of ways that event can happen like 3, and sample space can happen is like 6. Okay, so here probability will be 3 by 6, or we can say 1 by 2. Okay, so this is basic definition of probability. Now let's see the conditional probability. So conditional probability of any event E. Okay, let's suppose we have any event E such that its probability is some greater than 0. Let's suppose our event is like that. Okay, then let's suppose there is another event F. Let's suppose there is another event F, then probability of happening F when E is already happened. Probability of happening F when E is already happened, this is known as the conditional probability of f, and it will be equal to your probability of f intersection E divided by probability of E. Okay, this is the conditional probability of f when E has already happened. E has already happened. Okay, we can write it like here probability of E f intersection E will be like number of times E and f happening together divided by sample of space, and here also number of ways E can happen divided by sample space. Means in numerator and denominator we both have divided by number of sample of space, number of ways sample space can happen, so that can be divided. So we can write it like number of outcomes in f intersection E divided by number of outcomes in E. Okay, we can write it like this also. So this represents the conditional probability of f when E has already happened. Okay guys, thank you guys. Like my video if you have, and subscribe our channel, and if you have any doubt you can ask me in my comment box or in my website lecturesforfree.com, and you can download my handwritten notes from my website lecturesforfree.com. Thank you.